G'day everybody, just an in-depth tutorial on tyFlow actions rollout and using it with the value op. Alright, let's do a bit of a deep dive into this test action rollout. It's mainly associated with the conditional operators like the yellow operators, and let's talk about each one of these things, the symbols that appear here, how we might access custom floats through expressions or through script, and how we might use all that to manipulate particles. Where this is handy is if you're trying to keep all your particles within the one event, right? So rather than sending stuff out. So if we just look at this page here a little bit, right? If we have it set to ignore, then any data up here isn't updated. But the data down here is still updated. So this section here is still updated, right? If we select the delete here, delete option there, then the particles are immediately deleted if the condition is true. A lot of times we use it with the send out mode, and that basically means whatever test we're performing, right, it's going to send those particles out. Now we can send data to several custom floats here, right, and we're going to go over these in depth, and we're going to give an example of how we might use them so that you can adjust that learning to anything you need. If you want, you can pause the screen here to get a full-on explanation of what happens and when it happens, but we're going to go over some of this in the next couple of minutes. These are the condition operators that actually have a test action rollout, and next to each operator you got this little circle, right? And that's an indicator as to what is being asked of this operator as far as the output or what it's going to do, right? So when we haven't done anything with it, it just shows as this light gray, right? When it's in the send out mode, we get this bluish color, and it expects us to attach an event to that and then send out the particles that met the true condition, and then whatever we're going to do to those particles that met that condition will happen in the new event. We can set it to delete, in which case it shows like this red cross, and in that case any particles that meet the test condition are immediately deleted, and we can choose to send them out to a send the data to a custom float, in which case we create a custom float variable, and every time the condition is true it will update a value in this float operator, or this float channel, right? So the indicator that we see throughout is valid for judging what's going on with your condition operator. Now, as far as, for example, this find target, if we had a target somewhere, so that's our target, and we had some particles, right, that were out here somewhere in space, and they were supposed to find this target. For this find target operator to do its job and start sending the particles towards the target, it needs to have a valid selection in here. Now a valid selection would be the ignore, in which case the particles will find their target, right, but nothing will change here. The data down here will still be updated, but nothing else changes. And the other way that you could have the find target still do its job and not have to send it out would be to increment a custom float. So either of these two choices would have the particles finding their target but not trying to send the particles out, which means we could do something with them in value operators, or we could do some sort of other test or something and change behavior based on that test. So this screen more or less contains comprehensive data explaining an example valid flow, right? So we're going to burst some operators, give them a shape, we're going to position them on an icon in random location, and then we're going to find a target, in which case the target is this box, and based on their distance to this box, we're going to colorize them. You can see there's two yellow ones and one blue here, and we're going to have some script that outputs some data here so that we can understand what exactly is happening with our custom floats. And then we have an expression in our value operator up here that is actually controlling the color based on the data. So the first thing first is, this is a good screen to pause and read to get all the information. But first thing we want to know is, how do we get access to all of these custom floats? Well, first of all, we give them a name. Alright, so here I've given this one F test count. Now remember, everything is capitalized dependent. Everything's exactly what you write in one place, you have to repeat the other. So if, for example, I got a small f for indicating a float value, and then I got a capital T to start my test with a capital C to start my count. That's exactly how you would have to write it in your script or in your expressions, right? And so just to summarize all these kind of arrows, right? So A, we have to create some float channels, and we name them, and then we decide whether or not we're going to save data to them. Now I'm doing all of them because I want to evaluate what these channels are actually outputting and when they're outputting them, right? So because I didn't want my particles to be sent out, I'm activating this channel here, which is increment custom float. That means that this find target operator will now still do its job of finding the target, but instead of expecting us to send them out, it's just going to put data in this channel. Now, what data does it put in this channel? Well, that's what this code is going to tell us. And in this case, which is actually true for most of them, the test count is always going to increment a value that says when the test is true, right? So if it's true on frames 1, 2, and 3, we're going to end up having a value of 3 in here, for example. So that's just an increment. But the best bet would be to kind of set up some sort of code thing like this, and then slowly step through your time frame, your timeline, to see exactly what's going on, and then understand the values. And it also helps us find problems. For example, in this find target, right, I found that the float all values, which normally holds the distance for the test to be true. It's not always the distance, but good 80-something% it's the distance. For other tests where it's true or false, it returns true or false, for example, right? But this one here, for whatever reason, isn't being updated. I would say it's a bug, because it does get updated when the test is true. But normally when we have any of these condition operators, the save all test values normally saves the distance continually being updated to that channel, and so you could use that distance for some sort of conditional whatever you want in your value operator, right? In this instance, it's broken in the find target, and we found that out, or I found that out through printing all my data. So I think what I would like to say is, and I'm going to show you it bigger on the next screen, but what I would like to say is, this is a great section of code that you can reuse at will and modify to suit your needs, but it's a great way of sending out the data in some sort of nicely structured format up here, and so you can evaluate what's going on. What I would say is, even though I'm using a print all and it can handle hundreds and even thousands of particles, you really don't want to be sending that much data to this max script listener. So in your early testing stages or whatever, like here, I'm just doing 3. So I'm trying to understand what's going on, and I'll limit my number of particles being printed to this max script listener to 3 until I can figure out exactly what's going on by looking and evaluating this data. Then once you have that done, you can just turn off this script operator, right, because you no longer need it set to there, or you can limit exactly how many particles get sent to here through adjustments of the range, right? So this is a great little screen for reusage of code and self-teaching and understanding what kind of happens underneath tyFlow, under the hood kind of thing. Alright, just a quick shameless plug. I have a course on Udemy. It really is just more what you've seen, where we go into parameters and everything, and kind of in-depth information about tyFlow operators. It's called tyFlow Basics, the Missing Manual. When I first posted it, it was around 14 hours. It's grown to 24 hours and 24 minutes. I'm actually keep adding more stuff to it. So if you want to help me out, that's the way you can do it. Have a good one. So here's a bigger, more readable version of the code, right? So basically up here, I'm just kind of making a nice break format. So each time a frame steps through, I can kind of see when the new set of data is coming out in my MaxScript listener. So it just prints these 3 dots, and then I actually print this text out that says current frame, and then I use this tyFlow variable and actually print the frame number. So what you see on screen is what we saw in the previous screen, where it says current frame 2, right, for example. Then we step through all the particles, and we step through each of the indexes, right? Now, for us to get these custom floats that are over here, and right now I have all of them enabled because I'm looking at all the data at once, right? You can see here that I've done this ftest count variable. That needs to be written here exactly the way it's written there, right? And here in this line is a format of how you do that, how you get this float test count value from this channel and then put it into a variable in tyFlow script. Now, just to explain what's going on here, if you don't kind of know it, is we're defining a float value, which is just a decimal number value right here. And we're going to name that float test count. And it's going to hold the value for the particle that was in this channel. So in other words, we're sending the value that's in there over to this internal variable inside the scripting operator, so that we can use that value that was extracted from the channel. So now we have all these 4 channels saved to our own 4 variables here, and now we want to print that out to the MaxScript listener so we can see their values. And that's a breakdown of more or less what's happening here. And this is exactly, I will delete the scribble, this is exactly how you can use code in a script operator to access data in custom float channels. So here's some handy code, and it also shows you how to format it nicely to output it to the MaxScript listener. Having said all this, let's look at some actual results in Max. So here's my example Max file, and let me just refresh this. I have got caching turned off because I didn't want cache in this instance. I want to be sure that an update was forced every frame. So right now we can see that we got our script operator here, and we can see that we more or less have an exact copy of the script in the simulation step that I showed you in the previous screens. And this is a sample output, and this is the output from frame 0. Now, why do I have 2 conditional operators in here? Well, remember I said I found out that this wasn't updating this value properly, right? Like the test all value should actually show the distance to the target and update it all the time. It's not doing that. It's actually only doing it when the test is true. That means I can't quite use this data the way I wanted it, so I had to find a workaround. So that gives you an idea of the power of using this code in conjunction with printing to the MaxScript listener. So if we step through, we can see that the value is being updated in this MaxScript listener, the distance, right? So when I talk about float all test values, we can see here that the distance to the supposed target, which at this point I've got to the center of this cross as my target point, right? And the sphere just represents a distance test, and this is my box, which is part of the target. So we can see exactly where our target is in the middle of this box. Now if you were careful, you notice that the particles change color based on distance, and I'll explain that in a second. But you can see here what's going on. So we see every frame we're updating this value, and you can see that one of our particles must have been true because all of a sudden the test count increased here, and now we also have a value that says when true. Right, now unfortunately this value doesn't go back to off. Once it's tested true, there's always a value in here. Right, so even as these particles go back out and they're actually past their distance, blue means that they're at the target, right? You can see that the float test true doesn't go back to being 0. It just remembers the last closest value that the test was true. I hope I didn't confuse you with that, but anyway, so we can see what's happening here, all right, with our MaxScript listener, and how we can now use the data. You can see that the test count value is being updated every time the test is true, and we can see the event age at which the test was last true, sort of thing. So there's our data. So now that we have our data and we can be sure what it is we're seeing, right, we can now use that data to do something with, for example. And I'm going to keep it fairly simple. And here, to overcome my failure of a distance that's always being updated all the time here, right, I've created an object test. I'm testing against the box, right, and I'm doing a radial test of less than 1.5 centimeters. So, and I'm saving those values here, right, in our normal values. So in my expression editor here, I've got a complex expression to read it first, but basically all it says is if the distance, which is this F4 value, that's the distance to the target, right? If the distance to the target is smaller than 1, give the material ID a value of 1. And then I'm doing a more complex kind of example here where I'm doing if the distance to the target is greater than 1 but smaller than 2, then give it material ID 2. And then another one here, if the distance is greater than 5 but smaller than 10, give it material ID 3. And then finally, if the distance to the target is greater than 4, give it a material ID of 4. And when we look at our material ID setup, that's how we got a multi-subject material, and that's how we're applying the colors, and these will be the colors based on range. So in other words, the furthest out particle will get yellow if it's greater than 10, then it'll be green as it gets closer, red pink right before it gets to the target, and finally blue indicates that the particle is actually hit the target. So when we look at that closer, right, we can see where the colors are coming from. They're being applied by this expression that's been attached to the static ID value here. You can see it's applying the expression. So all this script file is doing is writing stuff to the MaxScript listener for debugging purposes and understanding values. The actual core work that's being done here is we're sending values to custom floats. Now, if we don't want all these custom floats, we just use the one we want. In this case, we really only want to know the all values, right? We don't really need these two right now, for example, right? We just want to know these all values. Now, we do need to do something up here because this conditional operator, for it to work and send data to different channels, needs to have something happening. So even if we're not using this ftest count, we still need it because otherwise it's going to not perform its job and it's going to expect us to do something else like either send out. Now, two options we have. We could send it to a dummy variable if we're not going to use it, or we could turn on ignore. It doesn't matter which way you do it, but you need something being you need the conditional operator to be told to do something here, right? It can't just be, if you send out, you've got to send the particles out. And in this case, we don't want to send them out, right? So the way that we have the conditional operator still do everything it's supposed to do is just to either select ignore or send to a custom float channel. And then the condition operator will do what it's being asked to do. So then obviously we're testing against the box for the distance, and then we have set a distance here, but in reality we're controlling everything right now with this value operator because we're looking at the value itself, this all value, right? And then we're making test conditions based on what this value says, and in this case it's the color. Now, why go to all this trouble and why do all this? Well, A, the code part helps us understand what's going on in our conditional operators. Sending it to the MaxScript listener definitely does, and once you're finished understanding, you just turn off or delete your script and never look at it again once you're sure you know what's happening with these test action channels, right? And B, sometimes you don't want to send particles out. For example, if we were having some sort of sine wave going here, and I'll see if I can show an example of that. If we have some sort of sine wave here and we want to do some sort of tricky material application to a moving sine wave, then we really don't want to send it out because sending out all the particles in the middle of a animating sine wave is going to cause an unexpected positioning of the particles. It won't be a continually nice flowing sine wave. So in that instance, you'd want to try and keep everything in one event. And this is an example of trying to keep everything in one event. And then, you know, we're controlling material ID, but it doesn't just have to be material ID. We could do many things. We could, instead of material ID as the test, we could, you know, do this value operator and an expression saying send the particles off at a different speed to all the others, whatever it be. I'm just using this as my example, but there's many different ways to apply this kind of stuff and expressions of value operators to your particles. Just having one final look at this setup here, right? Alright, so we've got two condition operators because find target has a slight value and doesn't update the all values. We're using the all values to assign material colors. We've seen the material and we've seen the expression that's in the box. Right, and we can see that right now we have one yellow particle here, one yellow there, and green. And this colorization is based on distance to our target, which is the center of this cross. And as the particles move closer and they meet our different test conditions in this expression, the material will be updated and applied to the particles. So as the particles move closer to the target center, you can see now we have the pink one, and then as they move right in, it's hard to see with the see-through, but there's a blue one, and eventually if all of them get into the middle and stay in the middle, they all eventually turn blue because they're within that target distance that we've set for the channel and that we're using in this expression. Alright, so that's kind of this particular example. Alright, and when we look at this, we go, oh my god, where did he come up with all this from, and how do I use this? I had a previous tutorial where I explained this in depth, and you might want to look that up. But for the completeness of this tutorial, I'll just show you what this looks like as a multi-line version of this code. Right now it's all been condensed into one single line, which makes it less readable. I mentioned that in a previous tutorial, but there is a lot of power in these expressions, and you can grab my code examples and hack away at them to your content and learn from whatever and just play around. So just to break down this code into a nicer looking format, here's our single line turned into how we would normally see it in multiple lines. This semicolon here defines the end of a line, right? So switch means switch whatever value meeting the test. So here we have 1, 2, 3, 4 different tests, and we're looking at the F4 values, which was the continually updated always value kind of, right? So which is, this instance right now is the distance to the target, right? So this is the distance to the target, right? And so what we're saying is if the distance to the target is less than 1, then apply material ID 1, right? So that's our material ID and 1. And then end of line, and then we can put multiple case conditions, as many as we want in here within reason, right, to give different colors or different speeds. For example, if you wanted to affect the speed differently as they get closer, if you, whatever it is you want to do. We're using color right now because it's also visual. Speed would be harder to visualize, right? So the second test case is if the constantly updated F always value is greater than 1 but also less than 5. So now we're saying if the distance to the target is in between these two, 1 and 5, then apply material ID 2, etc. That is what's happening in these lines. And this is the normal format that you would find a switch statement. And you can look up, the help for the expression part of it. But that's how we would originally visualize what we're trying to do, a more complex formula, and then break down the lines into their single line versions. So this here in the expression editor is always going to be harder to read if it's a complex formula. So there you have a bit of a reintroduction into this expression part, how we're using it to apply the colors, and how we're using the values in the action rollouts to get the data and display it in the MaxScript listener, and also use that data to manipulate our particles. Now remember, over here in this expression editor, it doesn't just have to be color. It can be many things. It can be speed, scale, rotation, I don't know, you name it, right? Just for the sake of completeness, I've just introduced a scale operator. I set the timing to continuous, so the scale is constantly being updated with whatever is in this expression. The value that we have in this expression is the same exact formula that we went through and is in here. All that's happening now is we're applying a scaling based on what's being sent back through this F all values, which is the distance to this central spot, so to speak, right? So as we get closer, you can see the particles get smaller and smaller and change color as well. So, and then depending on their distance to the target, they scale appropriately. So that was just to show you that it doesn't just have to be material ID. It could be many different things that you can think of as to how you might affect your particles. So to close out this tutorial, I'm just going to show you a sine wave here that's animated. Now right now the texturing is all done mathematically, and the height of the sine wave is being altered by changing the material. But the point being here is that we probably want to keep everything in one event, even though we're not using a condition operator here. We want to keep everything in one event because you cannot keep the continuity of the animated waveform from one event to the next. You'll get some sort of jagged edge, you'll get some sort of offset, right? So this is a good example of where we want to keep all our particles in the same event. Now, interestingly, you could use that distance test and everything I said to actually initially set some sort of material pattern like tyFlow writing or something like that. And we can see the waveform here, and you can see that I'm animating color number 2 to change the height of the waveform. But there's an example of the power of expressions. I'm using expression to drive 2 different values, the color and the text map here. And let's leave it at that for this tutorial. I'm going to have a fully in-depth tutorial being added to my Udemy channel or my Udemy class that's going to cover all this sine wave and noise stuff and things like that, and the texturing and plenty of examples. So there'll be definitely more detailed versions on my Udemy channel. Have a good one, everybody. Take it easy.